Absolute value inequalities. So you know how to solve an inequality. Reminder here. negative 2x plus 6. We solve this when you divide by a negative. Remember, the inequality reverses, so it's x is less than negative 3. Remember, interval notation. All values less than negative 3 would look like this. There we go. And you know absolute value equations. You set up 2 equations for each of the lines. Okay? And you solve each one of those. So now we're putting the two together. We are going to solve absolute value inequalities. And we're going to put things in interval notation. So remember, that's the ones with the square brackets and the parentheses and the infinity. Okay? So the first thing you got to do is you do have to isolate that absolute value just as before. Okay? So we keep that absolute value. And then that absolute value tells you I need to create 2 inequalities. So the first one, just like before, it's exactly the same. And the second one is that everything outside the absolute value changes. So 2x minus 4 is inside the absolute value. Inside. So that stays the same. These two things, the greater than 6, are outside. So we need to change them both. So greater than becomes a less than, and 6 becomes a negative 6. And that's really it. Then you just have to solve. So 2x is greater than 10. So x is greater than 5 is the first one. So this is negative 2. I am not dividing by a negative. The negative is not on the bottom, so those are my 2 answers. X is, so let's draw this, greater than 5. So that goes this way. And x is less than negative 1. Okay? So to interval notation this one, we have to just do 2 of them. We do this one, and we put a little or the u in between. So negative infinity to negative 1, and 5 to infinity. There we go. Okay, so this is the basic idea. Isolate the absolute value, meaning get it by itself. Create your 2 inequalities. The first one is exactly the same, and the second one you change everything outside the absolute value. Okay, same basic process, so add the 3. So we have the absolute value of 3x minus 6 is greater than 15. So this mess, the absolute value has to be bigger than 15. So the distance from 0 has to be bigger than 15. So that means that all the values, it's like the last one that we did, it's going to go outside the spots. Okay, so 3x minus 6 is greater than 15, and 3x minus 6 is less than negative 15. Solve each one of these. 21. So x is greater than 7. So that is a 9. And x is less than 3. So x is greater than 7, and x is less than 3. So greater than 7, that goes this way. So if we put any numbers in this range, it's going to make this absolute value true, inequality true, and 3 less than 3. There we go. So the interval notation, negative infinity to 3, combine that with 7 to infinity. Okay, so divide by 2 first. So x plus 2 is less than or equal to 6. So the absolute value has to be less than 6, so it has to get closer to 0 for this to work, not farther away from 0. So that's going to change our graph a little bit. So change everything outside the absolute value, so that becomes greater than or equal to negative 6. So x is less than or equal to 4, and x is greater than or equal to negative 8. So if we draw this, our 4 is here. Remember, it's colored in because it's got the equal sign here. Oh, I drew that the wrong way. That was stupid. Okay, so 4, negative 8, these are both colored in. Okay, so it has to be less than negative 4. Less than 4, so it's going this way. And greater than or equal to 8, so it's going this way. So it has to color in. So basically, whenever you have a less than sign here, almost every time, you have a less than, let's do it right here. Anytime you have a less than sign, when the absolute value is isolated, they're going to be connected. Anytime it's a greater than, it's going to go out because the distance has to get farther from 0. And this one, less than, means the distance has to get closer, so that's why they're connected there. So that interval notation is easy. It's only 1 because it's only one inequality. Okay, remember there's square brackets because these guys are colored in. Just happened. Sorry. Okay, so then try this one, try the next two, and we're good. I'm just going to do these. Remember, subtract your 2 first. Be careful. You can't combine the 2 and the 3. Divide by the 3. And now at this absolute value, it's less than 4. So you know whatever the numbers are, it's going to be an open circle, and it's going to be colored in this way. Anytime it's less than, that's what it looks like. So all I have to do now is solve these. And 2x minus 2 is greater than negative 4. And x is less than 3. So x is greater than negative 1. So the negative 1 goes here. The 3 goes here. Oh. There we go. And the last one, we simply divide by 3. So this is the exception behind that rule. So you still have to figure this out. So this is the absolute value of 2 times minus 4x is less than or equal to 6. So notice here, this is a negative here. You are going to be reversing the inequality, but it may not actually change. No, I don't think it changes. I think you can still say it's going to be colored in. So 2x, or 2 minus 4x is greater than or equal to negative 6. Solve each one of these. Negative 4x is less than or equal to 4. So here I'm dividing by negative 4, so x is going to be greater than or equal to negative 1. Remember, that's when you're dividing by a negative. Negative 4x is greater than or equal to negative 8. We're dividing by negative 4. So x is less than or equal to positive 2. Yeah, it still works out, see? We got a 2, less than or equal to 2. So it's going to be going that way. And greater than or equal to negative 1. And these two connect. So it's negative 1 to 2 as your answer. All right, have a good day.